Let's have a look at what happens when we call our API. We're going to focus on the response for now, as we'll start with getting data. So a request is sent, say, to get a movie poster, and the response comes in. Due to the nature of HTTP, the content comes streaming in over the wire, whether or not the client or the API is coded to work with streams or support streaming. When all the content has arrived, we can read it out from response.content. Up until now, we've done that with read as string async. This creates an in-memory string, which is as large as the complete poster response body. After that, we need to transform that string. We deserialize it into a poster object. For this, we use system.text.json. That's how it happens now. There's a few things going on here that we can improve. Let's start with that in-between string that's created. Instead of deserializing the object from a string, we can use a stream. That means that we no longer need the potentially large in-between string. It does not have to be created in memory first. This thus diminishes memory use and improves performance. Let's have a look at how we can do that. For this and the upcoming demos, we're going to use the posters endpoint of our API. You're looking at the controller backing this. As explained at the beginning of the course, this generates randomized sets of data, which are larger than what we currently get when getting a list of movies. We can see that by drilling into the getPostersAsync method on the posters repository at API level. Whenever a poster is requested, 500 random kilobytes are sent together with it. By working with larger sets of data, the improvements working with streams offered will become more apparent. Alright, let's switch to our client. The class we're going to use for the samples in this module is the local streams samples class. Let's cover the plumbing first, and by that I mean we inject an HTTP client factory and a JSON serializer options wrapper. As we're used to by now, we use constructor injection for that. Then let's immediately add a new method. We'll name this one getPosterWithStreamAsync. The first part of this method contains nothing new. We create a new HTTP client via the HTTP client factory. We create a new HTTP request message, which is a get message to one specific poster of a specific movie. We add an accept header and we send the request. Then we ensure a successful response status code. And then we have to start using a stream. So instead of calling read as string async on the response content, we call read as stream async. Behind the scenes, this uses a stream instead of an in-between string, as we've seen on the slides. And then we need to deserialize from this stream, and that's actually quite easy to do. System.text.json supports reading from streams, so all we have to do is pass through the stream when calling into deserialize async. The JSON serializer namespace has to be imported, so we add a using system.text.json statement. And we also have to pass through the type we are deserializing to, a poster. So we need to import the movies.client.models namespace as well. The deserialize async method accepts a stream. So that is what we pass through. And this is all that's needed to deserialize the stream into a poster. That being said, there's one more thing we have to take care of. In the previous demos, we never disposed of the request and response messages. When you dispose such a message, all it does is call dispose on the content. For string content and byte content, that's not necessary. It doesn't hurt, but it is unnecessary code. When we work with read as stream async, however, we are working with a stream content object, and streams do need to be disposed of. So in these cases, it is best to wrap them in a using statement. So let's do that. Let's wrap our response in a using statement so the response is disposed of which means the stream used to read out the content of the response is disposed of as well. There we go. Let's make sure we call this method from the runAsync method. And let's also make sure we register the local streams samples on our container instead of the HTTP client factory samples from the previous module. Let's add an async keyword here so this works again. And let's put a breakpoint right after the poster has been deserialized. And let's give this a try. We hit our breakpoint, and here is our deserialized poster straight from the stream. So this works. But is this really faster? Well, we're going to test that. But before we do that, there is another improvement we can implement. We're back at the diagram from the previous slide. We already improved one part. We're using a stream to get rid of the in-between string when deserializing, so that's good. But as we know, the content comes streaming in over the network. Yet, we only read out the content when it has fully arrived. That's because that async operation is only considered complete when that has happened. We can improve on that as well by considering the operation complete when the response headers have arrived, instead of the full content. By doing that, we're working on the underlying stream of content directly, which means less memory has to be used as the content doesn't have to be fully kept in memory. Moreover, it can also improve performance as we start working with the data faster. To allow for this, we have to manipulate the HTTP completion mode when sending a request. Let's do that in the next demo. In this demo, we're going to create a stream over the data that's transferred over the wire. I'm simply going to copy over the code from the previous demo. And let's give the method another name. There we go. Let's have a look at the sendAsync overloads. We can pass through the request and a cancellation token, which is coming up later, the request and an HTTP completion option, and the request and an HTTP completion option and a cancellation token. For now, we're interested in passing through an HTTP completion option and no cancellation token. HTTP completion mode can be used to specify when an async operation is considered complete, when all of the response is read or when only the headers are read. The default is that the operation should complete after reading out the entire response, including the content. But we don't want that. We want to start working on the response content as soon as possible, in other words, while it is still coming in. To allow for that, we set the completion option to response headers read. And that's it already. Let's set a breakpoint here. Let's make sure we execute this method. And let's give this a try. And that still seems to work. So far, so good. Time to test the improvements we get with this code. To test the improvements streams offer, we will need one additional method that gets a poster without using streams. That's exactly the same as what we did for movies when we created the CRUD sample class. So let me paste that in. There's nothing new here. We simply send a request and deserialize the poster. Alright, so we've got three methods to test here. Let's add a test method. I'm going to add a method that accepts a function which we want to test. Like that, we can nicely pass through our three methods here. All the methods we want to test return something, a task. So that is a type parameter we pass through to the test method async's func parameter. What we want to do is execute this function to test. It's that method that sends a request and deserializes it. We want to do that a number of times, after which we can calculate the average time it took for one method run. So we create a new stopwatch for this. Then we run a bunch of requests, say 200. We stop the stopwatch and we write out the results. One more thing we have to add is a warm-up request. When the first request to an API comes in, the API isn't necessarily fully set up and running yet. by executing the request once, we ensure that the first run doesn't interfere with our test results. So as a warm-up request, we execute the function to test once. Alright, that's our test method. In run async, let's execute this method. Once by passing through getPoster without stream async, another time by passing through getPoster with stream async, and lastly, once by passing through getPoster with stream and completion mode async. That's it as far as code is concerned. Let me set a breakpoint right after the results have been written out to the console output window. That makes it slightly easier to note them down, as there's quite a lot of stuff being written out to the console output window as is. To make sure API debugging doesn't interfere with our results, we're going to start the API without the debugger attached. So we choose Set Startup Projects at level of our solution. And as far as the movies.api is concerned, we change the action to start without debugging. Alright, let's give this a try. We hit the breakpoint for the first time. Let's have a look at the console output window. We are averaging 33 milliseconds per request. Let's continue. We hit the breakpoint again. This time we're averaging 29 milliseconds per request. That's already a little bit faster. We hit our breakpoint for the last time, and this time we hit 28 milliseconds per request on average. So as you can see, the things we did have an impact on performance. Moreover, next to having an impact on performance, they also have a positive impact on memory use. So far for streaming when getting data. What about posting data as a stream? We can do that as well